Hi everyone, it's Sharmila from Can Do Teach, and in this video we're going to be looking at factorizing two special forms of quadratics. So the perfect square and the difference of two squares. So let's start with perfect square factorization. So perfect square quadratics are quadratics that factorize down to the form x plus m squared. So rather than having two separate brackets multiplying each other, they are a single bracket squared. Okay? So a nice way to visualize how this will come out is actually with a square. And so each side of this square has length x plus m. So this part is x and this part is m. Okay, so to figure out what x plus m squared is the same as looking at the area of this square. So the area of this piece would be x squared. This would be x times m, so mx. This would also be m times x, so mx. And this little square would be m squared, m times m. Okay, so if we add all those together, we've got x squared, don't need the bracket, x squared plus mx, so we've got two identical pieces mx, plus m squared. So the special thing about the perfect square is that these two pieces are exactly the same size, mx. So we have 2mx and m squared. That's what we need to look out for to do perfect square factorization. So let's take the example where m equals 3. So x plus 3 squared is going to equal x squared plus 2 times 3 times x, so 6x, plus 9. So what we need to be able to do for perfect square factorization is to recognize by just seeing this that it's a perfect square and be able to factorize immediately to x plus 3 squared. Okay? So to do that, we first need to recognize that the 9 is a square number. Then we think, okay, that is 3 squared. So then double 3 should be here, 6. So if those two things fit, the square root of this times 2 is this number, then we're in business. Okay, so let's try that out in practice. So factorize y equals x squared plus 10x plus 25. So when I see this quadratic, I could do my product sum factorization to try and factorize it, but the first thing I would actually see is that this is a square number. So 25 is 5 squared. And so I would think to myself, is this a perfect square? So if I see 25 here, I would think that's 5 squared. So the square root of 25 is 5. And then double 5 is 10. So if that fits, the square root of this times 2 is this, then I know it's a perfect square and I don't have to do any product sum factorization. I can just go ahead and say x plus 5 squared. So if this fits, give it a tick, then this becomes the number here. Okay? So another way to look at it is if it's a perfect square, you get the square root of this term plus the square root of that term. Okay? We'll try one more. So x squared plus 8x plus 16 And so I'm looking at this, I know that 16 is 4 squared. Let's take the square root of it and I get 4. And then I double it and I get 8. So my factorized form is x plus 4 squared. Okay, so the other thing it can be is this sign can actually be a negative. So if we look at an example like that, that can also be a perfect square because the square root of 49 is actually plus or minus 7. So if I go plus or minus 7, and then double either of those should be this term. So in this case, because it's negative 14, the square root I should take is actually the negative 7 square root. Okay? So negative 7 times 2 is negative 14. So the perfect square I end up with is x minus 7 squared. Okay? So another way you can think about it is notice that this is a square number. It's a square. Then look at this number and say, what's half of it? Negative 7. What's negative 7 squared? Still positive 49. So it's x minus 7 squared. That might be a better way to go about it. Alright, so the last thing I want to say is just that just because this is a square number doesn't mean that it will be a 14 square. We always have to do the check. So let's say I had x squared plus 10x plus 100. Well, straight away I'd be like, oh, 100 is a square number. The square root of it is 10. And then I'd be like, but that's not double 10. So it's not a perfect square. And then I would have to go about it trying to do my normal monic factorization. Okay? So don't be fooled by just seeing a square number and immediately launching into your perfect square. Both things have to be true, that this is a square number and this is double the square root of that number. Okay? So that's our first special form of quadratics. The second one is called a difference of two squares. So in this one we also have square numbers, but this time we have a difference of two squares. So we've got x squared minus something else squared. So if I write 9, well that's actually 3 squared. Okay? So you may not immediately even recognize this as a quadratic because it doesn't have our normal 3 forms. But because it has an x squared in it, it is a quadratic. So we can try our regular monic factorization and then we'll notice a special pattern here. Okay? So in this case, I can actually write this as x squared plus 0x minus 9, which means that my a is 1 because it's monic, my b is 0, and my c is negative 9. So if I'm doing my normal product sum factorization, I want to find two numbers that multiply to give negative 9 and add to give 0. So we've never dealt with a 0b before, but which two numbers would multiply to give negative 9 and add to give 0? Well, if you're going to add to give 0, they should be plus and minus the same thing, right? So if they're multiplying to give 9 and they're the same size, then it has to be 3 and 3, and we'll make one of them positive and one of them negative. Okay, negative 3 times 3 is negative 9, negative 3 plus 3 is 0. So I've got my factorization. it would be x minus 3, x plus 3. Okay, so we can actually notice the pattern here, that this comes out to being the square root of this term, and these two come out to being the square roots of this term. So anytime we have two squares with a negative in between, we get this pattern, x plus the square root, x minus the square root. Okay, so we'll try another one. Let's factorize x squared minus 100 by a difference of two squares factorization. So we get simply an x and an x. The square root of this is 10. And we just put 1 plus and 1 minus. It's actually the easiest type of factorization we've got. So what do I do if I just have two terms, but it's not actually a square number? So let's say x squared minus 7. Well, I can still do difference of two squares factorization, but this time I'm going to get a third. So I do exactly the same thing. I put my two brackets with my two x's, and I put the square root of this term. So last time we had a 100, so the square root of 100 was 10. This time we've got 7, and the square root of 7 is root 7. So we can go plus minus root 7. And so it doesn't matter, even though it's called difference of two squares, it doesn't strictly have to be a square number this time. We can do it with a non-squared number, and it just means we'll end up with third factors. Alright? So lastly, we can look at an example that we still have two squares, but it's a non-monic difference of two squares. So let's try 4x squared minus 81. So again, we've got two square numbers and a difference between them. So this term has to have, this operation has to be a negative. So it has to be a difference of two squares. If it's a sum, we actually don't get any factors at all. So this one, again, we've got our two brackets, and we have to take the square root of this entire term into these two positions. So the square root of 4x squared is the square root of the number and x. So 2x squared is 4x squared. Sorry, 2x bracket squared is 4x squared. And then the square root of this goes into these two positions. So we've got 9 and 9. And then we just put the plus in one of them and a minus in one of them. And we're done. So these two special forms that we've gone over can be done with our regular monic factorization, but it's actually really important to learn to recognize them, because in a technique we're going to do later on called completing the square factorization, you actually need to be able to directly factorize using the perfect square and the difference of two squares to be able to do that method. So it's good to practice recognizing the two of them. It'll also save you a lot of time. So rather than sitting there having to figure out all the factors, if you just see that it's one of these two forms, then you can factorize in one step. So do some practice with those. Let me know if you are still confused at all. If you have any questions, you can put them in the comments below. Otherwise, you can always find one-to-one help at candoteach.com. So that's all for now. Thanks for watching, and I'll see you next time. Bye!